Welcome to Biological Molecules, OCR, and this is for the 2026, 2027, 28 exam boards updated. We are looking at biological molecules, and we're going to start at the very beginning, which is monomers and polymers, which is pretty straightforward, but throughout this topic, we're going to be applying the ideas of monomers and polymers to each biological molecule. Now, a reminder, all of these resources you can just get for free if you go to biobed.uk, log into the free app, and you can get them from the workbook section. So in this section, we're going to start on what the difference between a monomer and a polymer is. So a monomer is simply an individual unit of a larger biological molecule. So it's the smallest functional unit. So for instance, in carbohydrates, it's going to then normally be some kind of glucose molecule. And you will learn very soon, alpha and beta are the ones that we look at in year 12. When it comes to proteins, for instance, the individual units are amino acids. Even though there are slight changes to the variable groups, we still refer to them as monomers and polymers. And the third one is not fats. Fats and lipids are not polymers. They are macromolecules because they are not repeating units. And we'll cover that in 3.5 lipid. But the third one is nucleic acid. Now, we've learned as DNA as a big, large molecule, but it's actually a polymer of individual repeating units of nucleotides that are made of a phosphate group, some kind of pentose sugar, and then a nucleotide base. And again, those bases can be changed, A, T, Gs, and Cs, but one of those is a monomer, and then many repeating units is a polymer. Here's 4 examples of carbohydrates we'll look at later on. Cellulose, for instance, is repeating monomers of beta-glucose. Amylose, alpha-glucose, amylopectin is alpha-glucose, and glycogen is just alpha-glucose, but in animals in a more dense, compact way. We also need to be aware of the elements, and what decides what each of the biological molecules is really the ratio of those elements. So all biological molecules are built on the building blocks of carbon, hydrogen, and oxygen. Pretty much everything has to have those things. Organic chemistry really looks at carbon-based things. Now, the difference is nucleic acids are going to have nitrogen and phosphorus. Proteins are going to have nitrogen, and a large percentage of them are not going to have sulfur, but some of them, and the main amino acid we look at on the course is cysteine, is the only one that contains sulfur, but we refer to proteins as containing sulfur. And the difference between carbohydrates and lipids is the proportion of oxygen. Lipids have far less oxygen molecules than carbohydrates do. Now, there's many other useful ions that we're going to look at. I don't think it's useful to list them all now, but you're going to use them as we go, but I'll give you a few examples. Some really common ions you can look at are going to be potassium and sodium. And these, for instance, are used in nerve impulses. Or it might be a really other common one, might be nitrates or even nitrites that you're going to look at in year 13 when we look at the nitrogen cycle. Calcium ions are particularly common. We use them as muscle contraction in synapses and a few other places. And excretory molecules like ammonia or ammonium. For monomers and polymers, we're going to look at how they join together with condensation reactions, hydrolysis reactions, as we look at the individual biological molecules. But up next is water.